Welcome back. This is the second segment of section 7.1. Last time we derived the so-called law of sines, and then we applied that to a angle side situation triangle. I also want to show you how to do it to an angle side angle. It basically is the same process, except that the angles and side pair that you're using are the only difference. So basically, just to recap. Section 7.1 is always about oblique triangles that have two angles. Now, when you don't have two angles, it's very, very trivial to get the third angle. And then it's just a question of manipulating the law of sines, which is actually three equations to whichever things you have to find the things that you don't have. So let me move over here to the document camera, and I'm going to set up another situation. This time it'll be an angle side or angle side angle. So I believe I'm on page 3. So let's I mean, same sort of setup. I mean, I will draw an arbitrary triangle just so that we have the arrangement of the letters and the number or the letters, so that when I say, this is kind of preparing you for the way that you get given this information. Most of the time you don't get a triangle that's accurate. It may be out of scale. It could be an obtuse triangle and you wouldn't even know the difference. So in angle side angle, we have two angles and an included side. So let's say that, well, let's just mix the letters up here. How about B is equal to 103 degrees, and let's make C equal to 54 degrees. And so we need one of the sides that's not included. So anything but A, let's call, let's do little b. And so for little b, oh, sorry, no, we're doing angle side angle. We need the included side. So little a is the one that we'll have. Let's make that equal to, oh, I don't know, let's say 37 feet. So now I've actually added a unit. Go ahead and just mark that out so it's real clear what we're doing. A equal 37 feet. So just like before, we're going to calculate the third angle right off the bat. Now here's the reason why. Because if you look at the way the law of sines works for these types of solutions, you need to have pairs. You need an angle and its opposite side, angle and its opposite side, angle and its opposite side. So when we have angle side angle, we don't start out with that. Whereas in angle side, we already had a preferred pair. So we need to create this opposing pair where we must find A and little a to proceed. So again, we will just find the third angle first, and then it starts to look like the same sort of problem. So the first is to say, okay, well, A is equal to 180 degrees minus B minus C, which in this particular case, so 180 minus 103 minus 54. And if you don't trust yourself to do this by in your head, which is always a safe bet not to do that. So 180 minus 103 minus 54, we get 23 degrees. So A equals 23 degrees. Okay, so now that we have these opposing pairs, we have A, therefore we have sine of A, and the distance little a. Let's just go for the next side, which is B. So to find B, and I'm not going to do all the algebra again, but basically we have B equal to A times the sine of B over the sine of A. And I just remember these because it's like, it's the side you're wanting to get, the side you have, and then you have to make sure that the ratios of those signs is correct. So it's always numerator is the thing you're looking for, denominator is the thing you have, right? So that way it's sort of a shortcut, so you don't have to do the algebra every single time. So now we'll plug in the numbers. We've got 37 feet times the sine of 103 divided by the sine of 54, which sine divided by 54 sine equals times 37. So we come up with 44.5623421, and that's feet. Okay, so I'm going to get a little long on this page. I don't really necessarily want to cramp it, so I'll just carry this over to the next page. Now remember, this is going to be a number we're going to approximate. How many units does it have? 2, right? So this will actually come out to 45 when we write it all down, but so be it. All right, so the third step now is to find C, and we're going to use the same ratio, except we'll change angle B to angle C. So we have, you know what, I think I will just start it on the next page. So we're on page 4 now. Okay, so the governing equation here is that C, the side we're after, is equal to A, the side we started with. Now don't suddenly switch to B. That's kind of where people start to get into trouble. Because if you do switch to B, I mean, you can do that, but you have to carry this, you can't just use 45. You have to use this big, giant, long number, which doesn't make any sense. Just use 37. So that's just kind of where I was talking about. I mean, you do have some choice, but certain choices make more sense than others. So anyway, so it's A times sine of C over sine of A. And our known values are 37 feet times the sine of C, which is, as I recall, C was 54 degrees. And A was 23. I apologize. I think that back here, let me back up here a second. This is very easy to do, so I'm not totally shocked that I did it. I have the wrong angle here. This recall here that B is actually 103 and A is 23. Let me revise that. It's a good thing I left some space there. So let me recalculate. So 103 times the sine divided by 23 sine, and then multiplied by 37. Oh, okay. Times 37. Sorry, this should be 92.26726 feet. And since I'm a little bit weary, I feel like I fat fingered something. Let me just try it again just to make sure that I got the right number. So 103 sine divided by 23 sine times 40, or it's not 42, 37. And I get 92, 26, et cetera, et cetera. So it looks like that's okay now. Sorry about that. It does happen a lot, and so maybe it's good to actually see me do it once. Okay, so back to this calculation. C equal to A times sine of C over sine of A. So that's 37 feet times the sine of C. Verifying that that's correct. Yeah, C 54 and A 23. So we've got 54 times sine divided by 23 sine equals times 37. And we come up with 76.60927, etc. Okay, so now going back to summarize. So this is kind of, remember, this is something that for whatever reason, when people do these problems, they don't bother to do it. They just kind of write all this stuff out and go, see, I knew the answer. I think it's really critical to, once you do all this kind of scratch work, these calculations, to go back and summarize everything that you know about the triangle. So I'm hoping that you'll model the sorts of ways that I do these problems to be more efficient and more clear about what's going on. Because when you do make mistakes, like I made a mistake, it's much easier to catch them because you're constantly looking back at what you've done and where you're going. So remember, angle A was 23 degrees. Remember, this was calculated. B was given as 103, and C was given as 54. Little a was given as 37 feet. And B, now let's go back to where we calculated little b. Just to recall, look at what the inputs are. We've got 2 significant digits, 3 and 2. So this is a product. It should only have 2 significant digits. We need to round this. So this ends up rounding down to 92 feet. And then with this last calculation for C, notice it's 2 digits, 2 digits, 2 digits. The result should be 2 digits. It will round up to 77. So again, this is kind of that situation where for some reason people don't want to round that off. They want to write that as 76.6, which is false. Okay, so there's another example of a problem. You now have an angle side and an angle side angle. I could repeat these, but they would all just sort of look the same. I don't really have anything additional to add about these methods. These are actually some of the easiest methods. I suppose what we could do is we could, I mean, I don't even think this is a really good thing to emphasize, but I think possibly there's a homework problem that goes out there that talks about the area of a triangle. So maybe if we just do this real quickly, let's suppose that we have a triangle with side 12, 16, and an angle of say 40 degrees. Let's make it some 41 degrees. If you wanted to find the area of this triangle, this is the perfect setup because it has angle. It has the side. It has an angle. Just be real explicit here. That's this angle. So 41 degrees, and you've got two sides that are on either side of that angle. So side, angle, side situation. Very easy to find the area. You can simply say that the area is equal to 1/2 the product 12 times 16, and then times the sine of the included angle. So 41 degrees. So I usually like to do the things that have functions first. So sine of 41 times 12 times 16 times 0.5. We get 62.9816, whatever. Now this is because the products, nothing has more than 2 significant digits. Remember, this is not a measured number. So this actually has infinite significant digits, but we have measure, through 2 significant digits max. The answer will be 63 somethings. Now in this case, if these were feet or something like that, it would be, maybe if I just go ahead and put that on the diagram, it would be square feet because we actually have a product. Remember, areas are going to have a square unit. So that would be kind of an interesting deal if this was the setup we had. Now, what if we didn't have the side angle side? What if we had something else? Well, we could look back at one of these triangles that we just did, right? Any one of these and say, well, you know, maybe I've got the right sort of business. Here's the problem with that, okay? If you use these values, all right, you would need some combination of an angle, angle side angle. So for example, it might make sense to use this angle A and B with included side C. Because these are the 2 angles you were given in the problem. Or alternatively, maybe it makes sense to use A and angle B and C, which I would, or sorry, you need 2 sides, sorry. So if you were to take angle A, you would need B and C. Angle B, you would need A and C, and angle C, you'd need A and B. But every one of, both of these distances were approximated. So if you're going to try to do that, you need to go back and use the goofy numbers that have all the digits in them. Otherwise, you're going to create what's called a rounding error. But I don't think that this is really worth a whole lot of effort and time, because it's very rare that people are actually calculating the areas of triangles in most applications. Most of the time, what you're trying to do is find distances or angles between things. So I don't know that's particularly relevant, but maybe something to kind of fill the last bit of this segment with. So there are several examples. There are opportunities to do these in the homework. At this point, these do take quite a bit of time, right? Because you have to do these calculation after calculation. So I would suggest that the way to perform well on the next exam is to do as many of these as possible, so that it becomes really sort of second nature to go, boom, this is what I use to solve this. Boom, this is what I use to solve that. You also want to develop the skill of being critical, like I did in this last one. I blew it on the second on the finding distance B. So you constantly have to, once you've made a calculation, you want to keep thinking back about the calculation as you finish the rest of it. And it's fortunate that we caught it, otherwise I'd look kind of silly. Anyway, so this is the end of section 7.1, and I will see you in 7.2.